Sha'Carri Richardson. Scientists make shocking discovery tied to water physics. American sprinter Sha'Carri Richardson has stunned the world with her lightning-quick times on the track. But emerging science tells us that her talents could be a lot more astronomical than that. Scientists studying the biomechanics of tropical Jesus lizards, which are able to run on water, have said that under the right environment, a top-tier sprinter like Richardson can do the same. The Central and South American basilisk lizard is only 4 ounces, yet it can outrun predators by running on rivers and ponds. It does this by slapping its feet upon the surface, generating upward forces high enough to briefly sustain it. Scientists from Harvard University, Tom McMahon and Jim Glasheen, originally studied this phenomenon during the 1990s, dividing every splashing stride into 3 phases: slap, stroke, and recovery. In the slap phase, the lizard's foot slaps the water and produces lift. As it strikes, its swift leg movement creates an air pocket that prevents it from sinking. Last, the recovery phase gets the leg ready for another strike. This process, executed at lightning speed, enables the basilisk to run a few feet before gravity catches up. Applying these findings to humans, the researchers calculated that a 175-pound runner would need to reach nearly 98 feet per second, about 67 miles per hour, to skate across water on Earth. That is much quicker than even the quickest sprinters in history. Moreover, the power needed is 15 times greater than what a human can generate. But in reduced gravity, the impossible starts to look possible. Moons like Mars's Phobos or Saturn's Enceladus could provide the reduced gravitational pull needed to tip the scales towards a sprinter's advantage. At those scales, an elite-level athlete like Richardson would be able to generate enough power and speed to run on liquid surfaces without going underwater. The basilisk lizard's ability remains unique, but its mechanics offer interesting possibilities. Through the study of how animals interact with their environment, scientists are made aware of the boundaries of human potential. Richardson will not be racing lakeside anytime soon, but the idea that biology and physics could combine to enable it to do so elsewhere in the universe is enough to have fans imagining. For now, the world's quickest woman remains firmly rooted to the earth, but in the cosmic race of fantasy, she may already have 1 foot on water. Sha'Carri Richardson, a bolt of light, a splash on Titan. Prologue, the allure of the impossible. Faster than rumor, more magnetic than controversy, Sha'Carri Richardson electrifies every stage she graces. Her stride is poetry in motion, her speed, a whisper of rebellion against gravity itself. Imagine then that scientists, those diligent pursuers of the improbable, turn their attention not to the track, but to the shimmering surface of a lake on Titan, Saturn's hazy moon, and ask, could Richardson walk on water? Chapter 1. From Track Records to Titan Dreams. At the heart of this thought experiment lies a real headline. Scientists suggest Sha'Carri Richardson could, under certain extraterrestrial physics, run or walk on water. Vogue. Drawing from a Physics World article by fluid dynamics expert Nicole Sharp, researchers ponder whether Richardson's explosive running capabilities might translate to really walking or slapping on the surface of a liquid, ethane, under reduced gravity. Vogue. The Economic Times. Richardson's top speed clocks in at approximately 9.3 meters per second, an electrifying pace that earns her fastest woman alive status. The Economic Times. Vogue. But on Earth, even that vigorous sprint is far from enough to slosh against gravity and remain atop water. Chapter 2. Nature's Little Miracles, the Basilisk and the Water-Walking Birds. Enter the basilisk lizard, lovingly dubbed the Jesus Christ lizard, which elegantly sprints over water using a rapid slapstroke recover foot motion that traps air and creates a momentary cushion of support. Vogue. The Economic Times. Some water birds, like the western grebe, have taken this strategy to an astonishing extreme, up to 20 steps per second, compared to about 5 steps per second for Olympic sprinters. Vogue. Shine My Crown. Scientists have studied these creatures to understand how they defy gravity, if only fleetingly. Chapter 3. Earthly Barriers and Titanic Possibilities. Harvard researchers dug into the numbers and realized that a 176-pound human, with average foot size and stride rate, would need to slap the water at around 30 meters per second in order to stay afloat, a rate clearly beyond human capability on Earth. Vogue, the Economic Times. Yet science seldom stops at Earth's doorstep. In 2012, researchers at the University of Milan simulated reduced gravity environments, think lunar strength, and found that humans, in theory, could briefly run on water at gravity levels about 10% of Earth's. The Economic Times. This leap in imagination paved the way for its quirkiest chapter, running on Titan, where gravity is only 13.8% that of Earth's. Outsports. Vogue. That's where Richardson's modern myth begins, with her sprinting at 9.3 meters per second, surpassing the required 9m/s slap speed to stay aloft on Titan's ethane lakes. Outsports. Vogue. Chapter 4. A mind-bending tale of physics and wonder. Let's go deeper into the physics. On Titan, a runner's feet push down on the liquid surface and, with enough speed and lift, create a transient cushion, similar to the basilisk, but on a grand, alien scale. The lower gravity and liquid's properties could combine to make this fantastical feat technically possible. Imagine Sha'Carri Richardson, suited up in a futuristic friction-enhanced exosuit, toes poised at the edge of an ethane sea beneath Saturn's cloud-shadowed sky. The countdown begins. 3, 2, 1. She launches forward, and for a fleeting heartbeat, she slaps, pushes, and schemes across the surface, inertia and physics conspiring to hold her aloft. And in that moment, human ambition and cosmic curiosity collide. Chapter 5. The Poetic Power of Thought Experiments. Why does this scientific whimsy matter? Firstly, it reflects the human spirit, the urge to explore, to question, even to laugh at the borders of possibility. The theory that an elite sprinter might run on water somewhere in the universe becomes a playful celebration of both nature's marvels and human speed. Outsports. Vogue. Moreover, it casts Sha'Carri Richardson not just as an athlete, but as an icon of speed so exceptional that, even hypothetically, she could transcend our world's physical limits. It's a narrative that melds athleticism, science, and cosmic awe. Chapter 6. Richardson on Earth, Championships, Challenges, and Resilience. Backing up the celestial metaphor is a very real, grounded superstar. Born March 25, 2000 in Dallas, Texas, Sha'Carri Richardson shot to fame as a freshman at LSU in 2019, running a blistering 10.75 seconds in the 100m and becoming one of the fastest women in history at just 19 years old. Wikipedia. She powered forward, setting multiple national and championship records, and in 2023 claimed the World Championship gold in Budapest in a championship record 10.65 seconds, and added relay gold with Team USA. Wikipedia.